Hi, you guys. This is Mrs. Kang, and this is the notes video for modules 1-1 and module 1-2. So identifying integers and their opposites. And I will also be talking about comparing and ordering integers. So we are on page 19 first. So let's go ahead and start. So it says, an elevation of a location describes its height above or below sea level. And it says, which has an elevation of 0. That means sea level has an elevation of 0. So sea level is always at 0. Okay. Elevations below sea level are represented by negative numbers. And elevations above sea level are represented by positive numbers. So let's think about sort of like the ocean, okay? And let's think about a mountain, okay? So I know that we only see the mountain that is above the ground, okay? However, technically, a lot of mountains are actually like there's the part that's under the ocean. So let's just kind of think about that. So let's say here's a mountain and we have the water right here. That is called the sea level, okay? I mean, there's actually more to it, but just to keep it kind of simple for you to understand, this line right here is the sea level. And this is always 0, okay? In this case, 0 foot, okay? Because the unit that we're talking about here is in feet, all right? All right, so it is saying that any elevations that goes below the sea level, so below 0, are all negative numbers. So any of these elevations are negative, meaning the negative symbol here, and anything that's above the sea level are positive. Oops, my writing is a little, which means there's a positive symbol, okay? And you can also think about this as a regular number line, because if you were to turn this around, now instead of going vertically top to bottom, it goes to the right and to the left. So here's 0, and all of the numbers to the right are the positives, and all of the numbers that goes to the left are the negatives, okay? So here, I have a number line. If you take a look, I have 0, sort of like in the middle, and I have the positive numbers going to the right. 1, 2, 3, 4, like that. And if you notice, to the left, I have the negative numbers, and negative numbers start from -1, -2, -3, like that, okay? And all of these numbers are called integers, which we're gonna talk about in pretty soon, okay? So let's go ahead and go through A through E, and then I will give you the definition to an integer, okay? So A, it says the table below shows the elevations of several locations in a state park. Graph the locations on the number line according to their elevations. So let me just get a nice color marker. Okay, all right, so here are locations, and they have names, but I'll just call them A, B, C, D, E, and these are the elevations. As you see, some are positive, some elevations are negative. Okay, so let's go ahead and graph them. Remember, when you're graphing points on the number line, it has to be a closed circle for the most of the time and right on the number line. So like this, point A is at +5. So you go to 5, right here you do a circle. And even though they didn't ask you to do that, we want to label them if we can. So in this case, I will label it letter A. And we're gonna also, now we're going to plot the point -5, which is right here, and we'll call it B. C is negative 9. So further to the left, C. D is positive 8. And finally, E is negative 3. And we just did A. B, what point on the number line represents sea level? What did I say the sea level is? Sea level is 0. So this right here is the sea level. And that is 0.0. Okay. All right. C, which location is closest to sea level? Okay, now, so if you take a look, here's the sea level, and it doesn't matter whether the point is to the right or to the left of the sea level, which one is the closest to the sea level, you can clearly see that it is point E. So E, and how do you know? Well, negative 3 is located closest to 0. Okay. All right, D. Which two locations are the same distance from sea level? Are these locations above or below sea level? Well, let's take a look here. So sea level is right here. Which 2 points are the same distance from here? So let's take a look. Are this one and this one, so 5 and negative 3, same distance? No. This is 3 units from 0, and this is 5 units from 0. Okay, what about, oh, I have negative 5 here, which is 5 units to the left of 0. And I have positive 5, which is 5 units to the right of 0. So the two locations that are the same distance from 0 are these two, negative 5 and positive 5. So points A and B. So A and B. Okay. Are these locations above or below sea level? Well, 5 is above and negative 5 is below sea level. Or you can say point A is above sea level, and point B is below sea level. Either one works. Last one, which location has the lowest elevation? How do you know? Lowest elevation means it is to the very bottom, farthest away from 0. So lowest, so in this case, since there are negative points, negative locations, so none of these positive numbers are going to be the lowest elevation. Out of these 3, what is the farthest away from 0? Well, it's point C. So C is the lowest elevation. And how do you know? Negative 9 is located farthest from 0. Like that. Okay. All right, let's move on. So over here, you see a line. That line is not there just to separate the top and the bottom. It is so that we can actually practice drawing a number line. So first, I would like for you to draw 2 arrows to the left and to the right. And somewhere in the middle, I want you to draw a dash, and we'll call that 0. Okay, and I know that I have more space to the right here. I didn't mean to, it's okay. Now, what I want you to do is we're gonna draw several dashes that are equidistant. Maybe we'll just do 5 to the right and also 5 to the left, and try your best to make them the same distance, okay? All right, so now here is 0. Now I'm going to label the positive numbers, which are 1, 2, 3, 4, 5. So the positive numbers next to 0 goes in that order, 1, 2, 3, 4, 5, so on and so forth. And these are also called natural numbers or counting numbers. Including the 0, we call them whole numbers, okay? 1 through 5, 1, 2, 3, 4, 5, and on are called natural numbers. But when you include 0, 0, 1, 2, 3, 4, 5 are called whole numbers. Now, and they're also positive numbers. To the left of 0, we're going to start with -1, -2, -3, -4, -5, like that. So hopefully you guys can figure out that the bigger the negative number, the farther away from 0. Okay. Also, that means bigger the negative number, the smaller the value of the number. Okay, we'll talk about them more in detail later. Okay, now, so when you take a look here, you can see that I have 0 here, and to the right are my positive numbers, and to the left are my negative numbers. All right, so using that number line, I'm going to talk about the definition of integers. So right here, let's go. Integers are the set of all whole numbers and their opposites. That's the definition of integers. So let's go ahead and let's take a look at what integers are. Integers are a set of all whole numbers. So whole numbers are 0 through 5 and on, okay? So in this case, 0, 1, 2, 3, 4, 5, and it keeps on going, so I'll do dot, dot, dot. And they're opposites. Now, opposites are kind of common sense. Opposite numbers, which we're going to talk about the definition right here in a minute, but opposite of 1 would be -1. Opposite of 2 would be -2. Opposite of -3 will be +3. Okay, so it's the same number, but one's positive and one's negative. Those are opposite numbers. So their opposites are -1, -2, -3, -4, -5, dot, dot, dot. So this now covers all of the numbers that were on this number line. So integers are a set of whole numbers, so from 0 and the positive numbers, okay, and their opposites, -1, -2, so on and so forth. What integers cannot be are integers are not fractions or decimals. So for example, like 1 and 5/10, 1.5, that's not an integer, okay? Because integer has to be either whole numbers or their opposites, okay? All right. In other words, integers are positive whole numbers, negative, technically whole numbers, but I'm not going to put whole numbers here because technically whole numbers cannot be negative. So those are integers, and 0. Okay. All right. Now, so now that we kind of talked about integers, let's talk about the definition of opposite numbers. So opposites are numbers that are the same distance from 0, but on the opposite side. So let's consider two opposite numbers, 3 and -3, okay? Now, these two are opposite numbers, 3 and -3. Same number, but different symbols. One's positive and one's negative. Well, according to the definition, opposites are numbers that are the same distance from 0, but on the opposite side, to the right and to the left. Let's take a look to see if that's true. -3 is 1, 2, 3 units from 0. And positive 3 is 1, 2, 3 units from 0. They're both 3 units from 0. They're the same distance from 0, but they happen to be on the opposite side. Okay, now finally, what about 0? 0 is neither positive nor negative. Okay, so with that, we're gonna talk about one challenging question. It says, what is the opposite of the opposite of 3? So what we're going to do is first, we're gonna go inside out. So first, let's find the opposite of 3. What is the opposite of 3? Negative 3, right? Well, we found the opposite of 3, but what is the opposite of that? Opposite of negative 3 is positive 3. So the answer is positive 3. Okay, now the mathematical symbol for that is this. Sometimes we use the negative symbol to mean opposite. So opposite of 3, opposite of positive 3 would be negative 3. And the opposite of that, okay, now, so opposite of 3 is negative 3, and the opposite of that would be positive 3. Okay, and later in 7th grade, you don't need to really know this right now, but in 7th grade, you're gonna learn that when you have an opposite of a negative, so you have a negative here, and then you have another negative, then they become positive, okay? All right, now, since we talked about the basics of integers, let's now go to 1-2, which is comparing and ordering integers. So compare means you compare to see which number is greater than or less than. And then ordering integers means you order the numbers from least to greatest or greatest to least, okay? All right, so let's start with the first, ordering positive and negative integers. When you read a horizontal number line that goes from left to right, from left to right, so from left to right, when you're reading it this way, the numbers are in order from least to greatest. All they're saying is this, the numbers that are more to the left have the less value, so least. And as we go to the right, the number becomes greater. So least to greatest. Okay, so always the number that is to the right has greater value than the number that is to the left. Okay, so how do we use that to actually order the numbers? Well, let's take a look here. It says, graph the values in each table on a number line, then list the numbers in order from least to greatest. So let's go ahead and first graph. All right, so to use a brighter color. Okay. -5, +4, 0, -3, and -6, and +2. Okay, so how do I know which number is the least and which number is the greatest? Well, the least number is the number that, or least number is a number that is on the very, very left, which means -6 has the least value. Then it gets greater as you go to the right. So your answers are going to be -6, -5, -4. Oh, I'm sorry. -4 is not there. -6, -5, -3, 0, 2, and 4. Now this is in order from these two greatest. Okay, now with that, I have one thing that I do want you guys to write on the right hand side where there is room. What I want you to write is this. The bigger the negative, the smaller its value. And I also want you to write the smaller the negative, the bigger or larger its value. So what I'm saying is this: the bigger the negative number, the smaller the actual value of it. The smaller the negative number, the bigger the actual value of it. Think about it. This is closer to 0 than this, right? -3 is closer to 0 than -6. This number is to the very left, okay? The more the left, the smaller the value. We know that, okay? So the bigger the negative number, when you're comparing two negatives, bigger the negative, the smaller the value. The smaller the negative actually has the bigger or larger value. Okay, so let's go ahead and try the next one. Let's first plot out the points. 9, -1, -6, 2, -10, 0, 5, and 8. Now, so you have two options. When you're ordering the numbers from least to greatest, one of the things that you can do is first plot the points and then just go from left to right. So -10, -6, -1, 0, 2, 5, 8, and 9. But something else that you can do is, without graphing, you can look at the numbers, okay? We know that negative numbers have the least value. We have 3 negative numbers. Out of the 3 negative numbers, the biggest negative has the smallest value, which means this is my smallest value. The next biggest negative, which is -6, has the next smallest value, and then -1, and then 0. And now we have all the positives: 2, 5, 8, and 9. So you can do that mentally without having to draw the number lines. You can also look at the number line to make sure your answer is correct. Look, -10, -6, -1, 0, 2, 5, 8, and 9. You did it correctly. Okay, so this was ordering integers from least to greatest. Okay, what about just simply comparing and writing inequalities? Okay, remember we learned about inequalities in the previous module 2. I mean, unit 2. Okay, and inequality is a statement that says two quantities are not equal. The symbols greater than and less than are used to write inequalities. Okay, now to be honest, there are 2 other inequality symbols as well. So there's a greater than, less than, and we know that there's also greater than or equal to, or less than or equal to. But we're not going to deal with these right now. Okay, all right, so greater than, this symbol means greater than, and this symbol means less than. Okay, now we're almost done with the lesson. However, I do want to do one example. So can you guys please write this? Compare -10 and -8 using the inequality symbol. So the point I want to make is this: whenever you are comparing 2 numbers, you can write that same inequality, the inequality that has the same meaning, but you can write it in 2 different ways. Here's how. So first, let's do it in this order. So here's -10 and -8. So we know that -10 has smaller value than -8. The bigger the negative, the smaller the value. So -10 is less than -8. That's one way to write it. But I do want you to realize this. I can also switch the numbers So instead of putting -8 on the right, I can put it on the left. Then I would have to say -8 is greater than -10. So notice they both have the same meaning. Okay, this inequality symbol for both of them are opening towards -8, which is the greater number. But depending on the order that you use, you have two different ways of writing the same inequality. Okay, so here you go. All right, so that's the lesson. I hope you guys understood it. All right, okay, bye.